All right, welcome to the class for simplifying square roots of non-perfect squares. We already know how to simplify square roots with perfect squares because we just take the square root of them. So let's look at this first example. I'm going to do it in two ways, but let's just look at it as is. So 9's a perfect square. Perfect, but 2 is not perfect. So I can take the square root of 9 and I get 3, but I can't do that to the 2, but I know those multiplied together give me 3 square root 2, okay? So now one of our last lessons with square roots was multiplying square roots, so some of you might have thought to do it this way. 9 times 2, and then we would get square root of 18, okay? So which one's more simple? Well, first of all, we're going to say that square root of 18 is equal to 3 square root of 2. But which is more simplified? Okay? And it's this. This is the more simplified. More simplified. And the reason why is we can take 18 and factor it. So 1 and 18 and 2 and 9 and 3 and 6. Okay? So when we're simplifying radicals of non-perfect squares, we're going to look for factors that have a perfect square in it. Okay, so we would start with square root 18. We would break it into its factors of 2, of 9 and 2. We would break them up, and then we would finally get this. Okay? So simplify steps for non-perfect square, okay? Factor number under radical. Find factor pairs with perfect squares in it. Okay, so we're going to look at a few more examples of that. Okay, so let's look at square root of square root of 24. So the first thing I would do is factor 24. 1 and 24, 2 and 12, 3 and 8. And then, yeah, 4 and 6. So, which one of these pairs has a perfect square? This is the only one. But this can be rewritten as square root of 24 is equal to 1 times 24. Square root of 24 is equal to 2 times 12. Square root of 24 is equal to square root of 3 times 8. Square root of 24 is equal to 4 times 6. But if we simplify all these, it's actually, we're just gonna, we're still gonna get 1 square root 24, square root 2, square root 12, square root 3, square root 8, and then finally we'll get square root 4, square root 6, because we already knew that had the perfect square. Perfect square factor, so that becomes 2 times square root 6, so we get 2 square root 6 as our simplified term. Sorry, my marker. My marker is running out. All right, we're going to look at one more example. And then you should have enough information to move on to the handout. So, simplify square root of 80. So what are the factors of 80? 1 and 80. 2 and 40. 3, no. 4 and 20. 5 and, oh God. That's 5 and 8. Oh, it's sorry. 5 and 16. 6, no. 7, 8, 8, and 10. All right, I believe these are all of them, but it's late. So which one of these has perfect squares in them? We have 4 and 20. Oh, and we also have 5 and 16. These both are perfect. So, let's do it with the 4 and 20 first. So we're going to break that up to 4 times 20. That's going to break up to square root 4 times square root 20. And then we're going to get 2 square root 20. Now let's see if we got the same thing by breaking it up into 16 and 5. So we'll get square root of 16, square root of 5. Square root of 16 is 4. So we're going to get 4 square root of 5, but here we got 2 square root 20. So what's the difference? Let's look at the factors of 20 again. It's not simplified completely. All right, so here we have another perfect square. So we can say it's equal to 2 times 4 times 5 radical, which is equal to 2 square root of 4 square root of 5, 2 times, so that's going to give us 2 times 5, and then, yeah, that will give us our 4 square root of 5. Okay? So again, if we had chosen the larger perfect square, we would have done it in one step. But since we chose the smaller, we had to do it in two separate steps. All right. Good luck with the handout.